Okay, so welcome back to the next video. We're continuing here with our work on statistics. So, where shall we begin? Let's begin with linear interpolation. So, the next new idea, and it is a new idea, is something called linear interpolation. And the best way perhaps to describe this is to make you think back to cumulative frequency graphs. And you'll notice here the cumulative frequency graph, what am I doing? I'm taking some group data and I'm having a look at sort of plotting the frequency as it goes up. So keeping a running total, and that's called the cumulative frequency. So 0.55. At the end of the 0.55 group, you have 0.6, and you plot 0.655. The next one, you plot the endpoint 0.65, which is up here, and you plot the cumulative frequency, which goes up to 100. And what we're going to do is we're going to sort of investigate things like, well, as you see, if there's 150 pieces of data, we're going to investigate perhaps like the 75th piece of data. So this is sort of halfway, isn't it? Okay, or investigating n as sort of the halfway person. You know, we might do this for sort of the quarter person, or the person who is perhaps 10% in, and so on. And when you looked halfway, so when you looked at half of let's say half of 150, okay, you might remember that you could use a dotted line to sort of estimate this from a drawing. And notice that it's a line, okay? So we sort of go inside the line. Well, that's where the title comes from, linear interpolation. But we're going to do this without having to draw a diagram each time. That's the idea. So let's go back to this this point here. And what can we say about this point here? Well, first of all, if we look at sort of the middle person, okay, sort of the median, yes, the middle person, what do we know? Well, they don't appear in the first line segment, they appear in the second line segment. So they're actually part of the second group. And you can see that if we count up to 150, we go from 55 here to having counted 100 people here. So the 75th person must be in this box here. So they lie somewhere between 0.6 and 0.65. But I want to know, I want sort of a much better guess about where they are. I don't want to just say what's the median class, the median group. Okay, I want to get a bit more precise. Is it 0.61 or 0.62, and so on and so on. So hopefully, if I reveal this, this will make sense to you. So what happens when I'm looking inside this line from here to here? Well, the line starts when you talk about the 55th person, okay? Because the first group goes up to 55. So when you're counting onwards, okay, the person straight after, the 56th person, 57, 58, all the way up to 100, they're in this group. So we start counting from 55 in this group. 75 is what I'm interested in, okay? And the end of the group, it goes up to 100. So the top line here is just sort of saying, you know, the number lies between the numbers I'm interested in. And on the bottom line, I'm going to look at the actual heights. So what's the height at the start of the group? Well, it's 0.6, isn't it? And at the end, hopefully you can see there, that's 0.65. And I can use this information to sort of more accurately predict where the median person will be without having to draw it. So if we go back, in terms of the people on the top, there we go from 55 to 100. So 45 people are there. And can you see that we are 20 people in? We are 20 people in counting up out of the 45 people. And that gives us this fraction. So we are 20 people in. This is counting on from 55 to 75. And as you can see here, in fact, this number's in the table, there's 45 people there. And so the median, well, where is the median? It's wherever you start in that group, which is 0.6, and then we're going to add on. We're going to add on 20 45ths of this distance from here. So it's like 20/45, so a little bit less than half. It's like halfway through this group. And that's where this calculation is going to come from. So you start at 0.6 and 20/45 of the way through the group, this number is the distance from here to here. It's the difference. So our answer is going to be something like, I think this is 0.622 or something like that. And this would be our answer with the linear interpolation. So this is something that we do with grouped data to more accurately sort of predict or to estimate where maybe a median will be. But this doesn't have to just be a median. We could have done this for quartiles as well. So just as a quick example, if I wanted to investigate the lower quartile, this is a quarter of the way through. Well, what's a quarter of 150? Okay, so a quarter of 150, 75 is going to be 37.5. What group would that put me in? That would put me definitely in the top group. Okay, so I would be looking for the 37.5th sort of person out of how many? Well, that group has 55 people. What's the size of the group? It's actually the same as before. It's 0.05, but this is not always the way. So I am this far sort of into the group if I looked at the quarter position, and it starts at 0.55. So a nice calculation you can do would be this one over here, and this will give you an answer of something like 0.58 or something like that. So this is not only for medians. So I encourage you now to have a go at the questions on the board, okay, applying the same technique. So pause here and resume to see your answers. Okay, so assuming you have done this information you should be fairly happy with. 6/8 of the way through, okay, 16 take away 10 is 6, 18 take away 10 is 8, and the calculation looks something like this. Again, the number lies between these. So what's this going to be? This is going to be 3 out of 13, isn't it? 3 out of 13 of the way along, and so on. One thing you should be aware of, though, is many of the questions in the book will give you information like this. So if we're looking at the weights of cats to the nearest kilogram, and we have some information here, okay, this table may look incomplete, but actually we are able to bridge the gaps, aren't we? So have a think about a cat that was 12.2 kilograms. Have a think on this table about where it would go. Would it go in this box or this box? So it would go in this box because this is to the nearest kilogram. And this shows one thing that we can do, which is we can rewrite this. So we can do something like this. The top table, I might rewrite this as 9.5 until 12.5, because that is actually what is covered. 13, well, 13 means starting at 12.5, doesn't it? 12.5, okay, to 15.5. And so on and so on. You can write this with the correct inequalities, so you don't have any doubling up. But this is one step you will need to follow for linear interpolation. You need to make sure that sort of your classes cover all options. So even if this is something discrete, like in the exercise book with the lifts, you need to make sure that these connect up. Okay, otherwise you will not get the correct answers, because the width of the class in the table, it looks like it's 2, but actually we can see, for example, that it's 3. So instead of the gap being from 10 to 12, it's 9.5 to 12.5. The class width is 3. This will change your calculation when you do linear interpolation. And that takes you to 2C. And the advice here again is to avoid the quartile questions, as this is discussed slightly differently. Or if you do have a go at the quartile questions, please find them by doing sort of just a quarter of n, as you would do a half of n or 3/4 of n. The idea of n plus 1, okay, which was discussed in GCSE, is not going to be used at A level.